Hello, today we'll be talking about complement. Complement is a group of proteins in the blood that help the immune system fight infections. So complement can directly kill pathogens by forming many different complexes, which we'll cover in this presentation, as well as the different pathways and C3 convertase.
Hi, my name is Malia, and I will be going over the lectin and classical pathway. So this is the lectin pathway. It starts with the phycolin and the MBL, with the MASPs kind of in there. And basically, these bind to the surface of pathogens because they have a high avidity to the carbohydrates, such as like mannose, as you can see right here. And although they have different structures, they do basically the same thing, which lead to C4 and C2 being cleaved. And with the classical pathway, you have your C1 complex, which has a C1, R, Q, and S. And this also binds to the surface of pathogens and to antibodies. And yeah, basically it cleaves C4 and C2, so they bind, create C3 convertase, and later go on to create MAC. With the ester bond or domain is also important to help create those convertase.
Hey, my name's Hope, and the last pathway that we'll be discussing is the alternate pathway. The alternate pathway is unique because it begins spontaneously without antibodies. C3 in the plasma undergoes slow, natural cleavage into C3b. On microbial surfaces, C3b is protected from inactivation, unlike on host cells that carry regulatory proteins. Next, factor B binds to the surface bound C3b. Factor D then cleaves factor B, forming C3b-BB. This is the alternate pathway's C3 convertase. This enzyme is stabilized by factor P, which makes it more durable. Once stable, C3b-BB rapidly cleaves more C3, releasing C3a that drives inflammation and producing additional C3b for opsonization. This creates a powerful amplification loop, coating the pathogen with C3b and ensuring strong recognition by phagocytes. As C3b accumulates, the system progresses to the C5 convertase, leading to formation of the membrane attack complex, which lyses the pathogen. The key takeaway is that alternate pathway provides a fast, antibody-independent first line of defense against microbes. Now I'll be discussing the tipping point in the complement pathway, which is C3 convertase. So a convertase is a protease that converts complement proteins into their active form. C3 convertase is a crucial enzyme in the complement system, leading to cleavage of C3 into C3b and C3a. So if we dig in a little deeper, we can see that C3b is a larger fragment that covalently binds to pathogens or host surfaces. This is critical for opsonization, which is marking microbes for phagocytosis, and we're going to get a little bit deeper into that idea. So in order to bind to the surface, C3b contains a diester domain, or its head. This domain is described as functioning like a barb spring trap. This mechanism facilitates the attachment of C3b to surfaces. Then C3b acts as an opsin, marking pathogens for destruction. This activates macrophages via complement receptor, specifically CR1. The smaller fragment that diffuses away and acts as an anaphylatoxin, promoting inflammation by stimulating mast cells and recruiting immune cells. Let's explore C3a a little bit deeper. So after cleavage by C3 convertase, C3a is released into the surrounding environment. Think of it as the body's alarm system. It doesn't tag microbes like C3b, but instead it sounds the alarm. This triggers inflammation, making blood vessels leaky and calling in immune cells to the site of infection.
So next is the membrane attack complex, also called MAC. This is the final step of the complement cascade, and it's formed when complement proteins such as C5b, C6, C7, and then C8, and multiple C9 molecules come together. And these proteins assemble into a pore-like structure that inserts itself into the membrane of a target cell, often a pathogen or a bacteria. So once this pore forms, it disrupts the membrane structure and integrity, so it allows water and ions to rush in to the pathogenic cell, and this causes the cell to lyse and die. So in short, MAC acts as a pore which punches a hole in pathogenic cells and making complement incredibly powerful in immunity. All right, and then next, I'll be talking about a little bit about inflammation. So complement proteins also play a key role in inflammation. When the complement system is activated, proteins such as C3a and C5a are released. These molecules, called anaphylatoxins, act as chemical signals that attract immune cells to the site of infection. So they increase blood vessel permeability, allowing immune cells and proteins to enter the tissue way more easily. And so this is what we typically think of in inflammation that leads to redness, swelling, heat, and then pain. So in essence, this type of complement helps the immune system take action and ramps up the body's defenses.
Hi, my name is Ashley Sanjani, and I'll be talking about phagocytosis, it being one of the three main effective pathways that would help eliminate pathogens as in a disease. In this step, C3b is then connected to a pathogen to act as an opsonin, meaning that it's marked to be terminated. When the activating phagocyte is expressed, the receptors of the C4C3b, so that it would ingest a marked micropathogen to destroy it. In conclusion, the complement system is a viable defensive process that would keep pathogens and disease out of the host and healthy as possible, while using proteins and cascades to recognize and identify pathogens that could stop infections within the host, using the three main activation pathways, lectin, classical, and alternate. Thank you.